Hi class, today our topic of discussion is inequalities of triangle. Now in earlier classes we have already done that in an isosceles triangle, suppose I take PQR and I say that PQ equals to PR. I say that PQ equals to PR. It's an isosceles triangle. Then we know that the angles opposite to the equal sides are equal in magnitude, which means angle Q is equal to angle R. Similarly, if two angles of a triangle, suppose I take X, Y, Z, if two angles of a triangle are equal in magnitude, then the side opposite to the equal angles are equal in magnitude, which means if angle Y equals to angle Z implies your XY is equal to XZ. Now suppose we take a scenario, we take a triangle ABC, look carefully, ABC, and AB not equal to AC. And in this case we can clearly say that AC is greater than AB. Then how are the opposite angles related to each other? We'll see, if you calculate, then we'll see that angle B will be greater than angle C, which means in a triangle if two sides are unequal, then the longer side has greater angle, opposite to it. Let us see the proof for this theorem. Now let us look at the proof of the theorem, which says that if two sides of a triangle are unequal, then the longer side has greater angle opposite to it. We have taken a triangle ABC and clearly AC is greater than AB. We need to prove that this angle is greater than this angle. Okay, let us see. First of all, what we'll do? Construction. What I'll do? Take a point D on AC such that AB is equal to AD. So what I've done, I've taken a point D on AC such that AB becomes equal to AD. Now look at the proof. In triangle ABD, if you look carefully, angle ABD will be equal to angle BDA. Why? Because AB is equal to AD. The angle opposite to the equal sides are equal in magnitude. So we got this angle is equal to this angle. Now look carefully. In triangle BDC, if you look, this angle is the exterior angle, and exterior angle is equal to sum of opposite interior angles, which means, can I write angle BDA is equal to angle BBC plus BCD. Why? Because exterior angle equals to sum of opposite interior angle. We know this, which clearly means that BDA has to be greater than angle BCD. No doubt in that, because this is equal to the sum of two angles. So it has to be greater than one of the angle. Now look carefully. If BDA, instead of BDA, can I write ABD? So I'll write angle ABD greater than angle BCD. I can write this. Clear? Now look carefully. This angle, if you see, angle ABC in triangle ABC, angle ABC has to be greater than ABD. No doubt in that. Because why? Angle ABD is a part of angle ABC. Am I clear? Now look carefully. I can write angle ABD is greater than BCD. So I can write angle ABC greater than angle BCD. And look carefully. Angle BCD is nothing but BCA, which means angle ABC greater than angle BCA. Hence, proved. Done. Now let us look at the converse of this theorem. Now let us look at the converse of this theorem, which says that if two angles of the triangle are unequal, the greater angle has longer side opposite to it. We have taken a triangle ABC and I have taken that angle B is greater than angle C. Then we have to prove that AC greater than AB. Now we know property of real numbers. AB and AC are two real numbers. Then three cases arises. We'll take the first case. Suppose AB is equal to AC. Case 1. Now if AB equals to AC, then we know clearly angle B is equal to angle C, which is not true because that is not given to us, so not possible. One more case, I can take AB greater than AC. Now when AB is greater than AC, then angle C becomes greater than angle B according to the theorem, which is also not true because that is not given. Our given thing is what? Angle B is greater than angle C, which means there's only one case left, which is AC greater than AB. Done. Now let us look at the next theorem. Now look at the next theorem, which says that the sum of any two sides of a triangle is greater than the third side. We have taken a triangle ABC and we have to prove that BA plus AC greater than BC. Let us see the proof for this. What I'll do, again I'll do a construction. What is the construction? I'll produce BA to BD such that AC is equal to AD. So what I'll do, produce BA to D such that AD is equal to AC. Now look at the triangle ADC. In triangle ADC, this angle and this angle will be equal, opposite to equal side. Angle ACD is equal to angle ADC. ADC, opposite to equal sides. Now clearly this angle is greater than this angle. Can I write angle BCD, angle BCD greater than angle ACD, angle ACD, because ACD is a part of angle BCD. Now look carefully. Can I write angle BCD instead of ACD? I can write ADC. ADC, sorry. I can write ADC, this angle. Now look carefully. In triangle DBC, we just got this angle is greater than this angle. We just got angle BCD greater than BDC, which means by this theorem BD will be greater than BC. Am I clear? So what we got? We got BD greater than BC, because if two sides are unequal, then the longer side has greater angle opposite to it. So this is the longer side. Now BD you can write as BA plus AD. Am I clear? And AD is nothing but AC. Am I clear? So BA plus AC is greater than BC. Clear? Now look at one more theorem in this chapter. Now the third theorem states that of all the line segments that can be drawn to a given line from a point not lying on it, the perpendicular line segment is the shortest. Let us see what it is. suppose we have a line L and we take a point P and we drop a perpendicular PN, and Q is any point on the line L. We need to prove that PN is less than PQ. The shortest is the perpendicular line segment from that point P. Now let us see. Let us join PQ. Now once you join PQ, see, in triangle P and Q, angle P and Q is equal to 90 degree, and the three angles add to give 180, which means these two angles have to be acute, which means can I write angle P and Q greater than angle PQN? Angle PQN. Why? Because angle PQN is an acute angle less than 90, which means see, P and Q is greater than PQN, which means by the first theorem PQ will be greater than PN, which means I can write PN less than PQ. Done. Okay, now let us look at the sums from this chapter. Now look at exercise 10.4. Now before starting this, look at this. What I told you, the sum of two sides is always greater than the third side, which means can I write this as BA greater than BC minus AC, which means BC minus AC will be less than BA, which means I can also say that the difference of two sides is always less than the third size. Now look at sum number 3 from exercise 10.4 M L AGGARWAL, which says that PQR is a right angle triangle at Q and PQ to QR is 3:2, which is the least angle. Now look carefully. First of all, we draw the triangle PQR, given angle Q is equal to 90 degree. Definitely angle Q is greater than both angle P and angle R, because sum of the angle is 180 degree. Now look, PQ is QR is 3:2, so I can take this as 3x unit and this as 2x unit. Now look carefully, can I write PQ greater than QR, which means can I write opposite to PQ you have angle R, so angle R is greater, opposite to QR you have angle P. Why? Reason, because longer side has greater angle opposite to it, which means angle P is the least angle, because Q is greater than P and R, okay, and R is greater than P. Now look at number 5. In a triangle ABC, angle A is equal to 50, angle B equals to 60. Arrange the side of the triangle in ascending order from small to big. First of all, let us draw the triangle. Suppose I draw ABC. A is 50 degree, B is 60 degree. First I'll find angle C. Angle C will be equal to 180 minus 50 plus 60, which is angle sum property, that is all the three angles add to give 180, which means angle C is what? 180 minus 110, that's 70 degree. So this is how much? 70 degree. Okay, which means I can write angle C is greater than angle B is greater than angle A. Now opposite to angle C you have AB greater than, opposite to B you have AC greater than, opposite to A you have BC. What is the reason? This converse, greater angle has longer side opposite to it. Okay, they have told ascending, which means small to big, so we can write this BC less than AC less than AB. Done. Now let us look at the next sum. Now look at 7. It says in the adjoining figure, AD bisects angle A. Arrange AB, BD and BC in the descending order of the length. First of all, try to find all the unknown angles. In triangle ABC, angle BAC will be 180 minus 60 plus 40, angle sum property, which means can I write angle BAC 180 minus 100 degree, which is 80 degree. So this entire is 80 degree. Now AD is the bisector of angle A, which means can I write this angle, angle BAD is equal to 80 by 2 is equal to 40 degree. Why? Because AD bisects angle A. Similarly, so this becomes 40. Similarly, DAC, angle DAC, same case, 80 by 2, that's 40 degree. Why? AD bisects angle A, which means this is 40 degree. Now we'll find this angle and this angle. Now look at ABD in triangle. In triangle ABD, angle BDA is equal to 180 minus 60 plus 40. So that's 180 minus 100, that's 80 degree. So this is your 80 degree. And this is how much? This is 180 minus 80 linear pair. I can say angle ADC. Angle ADC is equal to 180 minus 80. That's 100 degree. That's linear pair. So this is 100 degree. Now look at triangle ADC. In triangle ADC, AD will be equal to DC. Why? Because it's an isosceles triangle. Look, angle DAC is equal to DCA. Hence, the side opposite to equal angle are equal in magnitude. Now look at this triangle ABD. In triangle ABD, look carefully. Descending order means big to small. So angle ADB is greater than ABD. ABD is greater than BAD. Okay, which means angle ADB opposite to this angle you have AB. So AB will be greater than ABD. Opposite to ABD you have AD. And BAD we can write opposite to BAD what you have BD. Am I clear? Now look carefully. AB instead of AD, can I write DC? The reason over here is this: if the greater angle has longer side opposite to it, greater angle has longer side opposite to it, we need to write the reason. So this is the descending order. See, AB, BD and DC. Done. Now let us look at the next sum. Now look at sum number 8A. In the given figure, prove that CF is greater than AF, and number 2, DC is greater than DF. First thing, try to find all the angles of this triangle and this triangle. Look at triangle EBC, I'm first talking about. In triangle EBC, I can write angle BCE is 180 minus 65 plus 90. This is given 90. This is angle sum property, which means this is 180 minus 155. This is 25 degree. So we got this as 25 degree. Done. Now look at triangle DFC. equals to 180 minus 65, which means this is 115 degree. So this we got as 115. Now look at this angle. Look at triangle AEC. In triangle AEC, if you look, angle ACE, angle ACE is 180 minus 90 plus 60. That's angle sum property. Come on, this is 90, so this is 90 and this is 60 given to us, which means this is 180 minus 150, that's 30 degree. So this is your 30 degree. Done. Now look at these two triangles. First I look at CF and AF. This triangle. In triangle AFC, they told to compare CF and AF. Look carefully. This angle we got. This angle. No, we didn't get this angle. First we need to find CAF. Look carefully. I'll do one more thing. In triangle AFC, can I write angle FAC? Angle FAC is equal to 180 minus 115 plus 30 degree. These two, okay? That's angle sum property, which means this is 180 minus 145, that's 35 degree, which means this is 35 degree. Now look at triangle AFC. Look, angle FAC is greater than FCA, which means, can I write CF is greater than AF? Why? This is the reason. Greater angle has longer, you need to write the reason, longer side opposite to it. Done. Now look at triangle DFC, because these two sides are from DFC. In triangle DFC, they told this and this side. So clearly look, DFC, angle DFC is greater than DCF, which means DC will be greater than TF. And what is the reason? Same. Done. Now look at the next sum. Now look at this sum, very interesting. 9A, they have told in the given figure angle B is less than angle A and angle C is less than angle D. We need to show that AD is less than BC. Very easy. In triangle AOB, look carefully. Angle B is less than angle A, which means opposite to B you have AO, which means AO will be smaller and opposite to angle A you have BO. Isn't it? What is the reason? This one? Greater, you need to write the reason. Greater angle has longer side opposite to it. Done. Suppose this is your equation 1. Now look at in triangle similarly DOC. What they have given? They have given angle C is less than angle D. Now opposite to C we have OD. So I can say OD is less than, opposite to angle D we have OC. Isn't it? And what will be the reason? Same as this. Suppose this is your equation 2. Now what do? You add 1 and 2. Add 1 and 2. What do we get? AO plus OD less than BO plus OC. Now look carefully, AO plus OD is nothing but AD. So AD is less than BO plus OC is nothing but BC. This is proved. Done. Now let us look at the next sum. Now look at this sum. Very interesting. In the given figure, D is any point on the side BC of triangle ABC. If AB greater than AC, given, what is given to us? AB greater than AC. Show that AB is greater than AD. Now look carefully. In triangle, I'm first talking about ABC. AB is greater than AC. So opposite to AB, you have angle C. So we can say angle C is greater than, opposite to AC, you have angle B. Is it clear? The reason is what? This one. Longer side has greater angle opposite to it. Done. Now look carefully. This angle, okay, for the triangle ABD, exterior, this exterior angle ADC will be equal to this angle plus this angle BAD plus ABD. Why? Because exterior angle is equal to sum of opposite interior angle, which means, can I write angle ADC is greater than ABD, is greater than, or BAD, whatever. Done. Now look, ADC is greater than, now this angle is greater than this angle, which means I can write angle ADC greater than ACD, greater than ACD. Why? Because angle ABC is given greater than ACB. This is already given. Am I clear? Now look at the triangle ADC. In triangle ADC, look carefully. This angle is greater than this angle, which means, see, angle ADC is greater than angle ACD, which means this side AC will be greater than this side AD. Okay. Now AB is greater than AC, already given, and AB is greater than AC is greater than AD, so we can put over here AD. Am I clear? This is done. Now let us look at the next sum. Look at the last sum for this chapter. Is it possible to construct a triangle with length 4 cm, 3 cm and 7 cm? Now look carefully. 4 plus 3 is equal to 7, which means the sum of two sides is not greater than the third side, which is not possible. It has to be greater than the third side, okay, which we have done. Okay. 10b. Is it possible to construct a triangle with length 9 cm, 7 cm and 17 cm? Again you see 9 plus 7, that's 16, and 16 is less than 17. So this is also not possible. When you add two sides, it has to be greater than the third side. Now look at the last one. Is it possible to construct a triangle with length 8, 7 and 4? Now look, 8 plus 7 is greater than 4. Similarly, 7 plus 4 is greater than 8. And similarly, you can say 8 plus 4 greater than 7. In all the cases, the sum of two sides is greater than the third side, which means in this case, the triangle is possible. Okay, keep it till here and take care.